complementary events are probably best described with a diagram. Once again, if this is all the sample space and this is event A, then everything else is event A, we call it A dashed, which is the complement of A. It's everything else, so it's all other outcomes other than A. So A and A dash are mutually exclusive, obviously. So, and A dash is the complement of A. Now, if we looked at the probability of A, and we added it to the probability of the complement of A, or A dash, that will always add up to 1. And we can rearrange that rule for probability of A equals 1 minus, just take that to the other side, the probability of A dash. That may come in handy, and it may be a quicker way of working out some probabilities. So let's look at an example. Say you toss 6 coins. And which is exactly the same as tossing 1 coin 6 times. What's the probability of at least 1 head? What's the probability of getting at least 1 head? Now, at least 1 head is event A in our diagram up above. So we want to know, we can use this formula here. So if we worked out the complement of at least 1 head and took it away from 1, we'll get the probability of A. Okay, so event A is at least 1 head. And what is at least 1 head? Well, it doesn't include 0 head, so it's 1 head, 2 head, 3 head, 4 head, 5 head, and 6 head. And we want to find the probability of that. So what are all the possible outcomes? What is the total sample space? Well, the only thing we've got to add to that is 0 heads. So that is a possibility. You toss a coin 6 times and get 0 heads. So the complement of at least 1 head is 0 heads. So the complement of at least 1 head is 0 heads. So we can just, so 0 heads will be A dash, so we've got to find the probability of 0 heads. So probability at least 1, which is A, probability of at least 1 head equals 1 minus probability of 0 heads equals 1 minus, now probability of 0 heads. That means we've got to get 6 tails. And probability on the first toss of getting a tail is a half. Probability on the second is also a half. So it's a half on the tail on the first tail and the second tail, so 6 tails. So each of them will be a half, so it'll be to the power of 6, not times 1/6, but to the power of 1/6. Because you've got to get a tail first, and a tail second, and a tail third, and a tail fourth, and a tail, and n is multiplied. So a half to the power of 1/6. Working out a half to the power of 6, 1 to the power of 6, 2 to the power of 6 is 64, so it'll be 1 minus 1 on 64, which will be equal to 63 over 64, and you subtract the 2. Now that is a much quicker way of doing this question than just working out the probability of 1 head, 2 heads, 3 heads, 4 heads, 5 heads, 6 heads, because 1 heads is 1 heads and 6 tails, and the head could be first, or it could be second, or it could be third. So just to work out the probability of 1 head is not as simple as it looks, and same with these other ones that you've got to calculate. So this works out to be a much quicker way of working out this question using the complementary events and the fact that the probability of A plus the probability of its complement is equal to 1, which allows us to rearrange that formula.